The diagram shows the curve y equals f of x, where f of x is equal to this polynomial, cubic polynomial here. Verify that the curve crosses the x-axis at 3, 0, so either there or there, and hence state a factor of f of x. Express f of x as the product of a linear factor and a quadratic factor. Hence find the other 2 points of intersection of the curve with the x-axis. The region enclosed by the curve and the x-axis is shaded in the diagram. Use integration to find the total area of this region. So here's the question in summary form here. Here's y equals f of x. At 3 naught, so we've got our polynomial then, our cubic. So we need to work out f of 3 and see if it equals 0. It's minus 4x cubed plus 9x squared, isn't it? Plus 10x minus 3. And the input value is 3, so let's see if we get a 0 when we put these in. What are we going to get? 3 cubed is 27. 4 27s is 108, so it's minus 108. Tap it in the calculator if you need to. 9 nines, 3 squared is 9, 9 nines are 81. 30, 10 threes are 30, minus 3. So you've got 27 here, and you've got 3 27s, so that's 4 27s is 108. That's going to be, isn't it? Minus 108, so it does equal 0. So x minus 3 then. So by the factor theorem, x minus 3 is a factor. Okay, of f of x. So part 2 then. Express f of x as a product of a linear and a quadratic factor. So we need to do some division to find out the quadratic. So that's the best thing to do here because it's leading us in that direction, isn't it? So let's divide that into our cubic, which is minus 4x cubed plus 9x squared, isn't it? Plus 10x minus 3. So here's our function of x. So let's do the division. Look at the term here, that's an x. Look at the dominant term, x cubed. How many x's go into that? It's minus 4x squared, isn't it? So multiply through. That gives us the minus 4x cubed. And then multiply this by this. You get 12 lots of x squared. Take them away from one another and find out what's left. So this cancels, that's why we're doing it. 9 take away 12 is minus 3x squared. And then 10x, take away none of them, is just a 10x. And minus 3, take away nothing here, is minus 3. Now we ask how many times does x go into this? Well, the lead term here, dominant term, it goes in minus 3x's, doesn't it? Multiply through once again, so we repeat the same process. Minus 3 times x is minus 3x squared, and minus 3x times minus 3 is plus 9x, isn't it? Take them away again. See what's left this time. This take that will cancel, that's why we're doing it. 10, take away the 9 is just an x, and then we've got the minus 3, take nothing is minus 3. So how many times does x go into x is once, plus 1. So let's multiply through. One lot of x is x. One lot of minus 3 is minus 3. Take them away, and we do get the 0 as we wanted. So x minus 3 goes into this function then, this cubic, this many times. So here we see that f of x, our cubic polynomial, is equal to x minus 3, which is a factor, of course, and this here, which we can write as minus 4x squared minus 3x plus 1. Let's write it like that. Okay, so there's our linear factor and our quadratic in the product. So that's done. Hence find the other 2 points of intersection of the curve with the x-axis. So we need to factorize this. Does it factorize or not? I'm inclined to think it does. So let's have a little look at it then. So this is equal to x minus 3. Let's do minus 4 x and an x. And let's put a 1 here and a -1. I put a 1 there because I knew that was a big minus, so it had to be 1 ones, and that's only going to give a minus. So why don't I try a 2 and a 2? So let's get rid of that and that. Let's just get rid of these contents then. And let's see, try the other one, the 2 and the 2, because that one I don't think worked. -2x and 2x. A 1 and a 1, they both have to be minuses. And that still won't give -3. So it looks like we're going to have to use the formula here. Doesn't look like it factorizes easily. So here, let's go back up to the question then. We've tried factorizing it. We've done that. Hence find the other 2 points of intersection of the curve with the x-axis. So the other 2 points will be the solution of this. So this is part 3, I believe. Here, in this case, x's, the x values will equal -b. -3 is 3, plus or minus the square root of b squared. B squared is 9, -3 squared is 9, -4 times a, which is -4, so that changes that to a plus, -4a, which we've done, times c, which is 1, all over 2a, which is 2 lots of -4. So this equals to then 3 plus or minus 81 plus 16, 4 fours are 16, 91, 97, square root of 97 over -8. So that's equal to, let's get our calculator then. It's 3 plus the square root of 97 of 97. Now put a bracket around that, and we want to divide that by -8. So let's divide by bracket -8 bracket equals. So let's go back. Let's get rid of that bracket there and put the bracket outside the square root. That helps, I think. And we get -1.61 to 3 significant figures. And the other one. Now it's 3 minus, it would be, wouldn't it? 3 minus root 97. So toggle back and put a delete there, put a minus in. And that would equal 0.856. 0.856. And that's the 3dp. So if we look back at our picture to have a visual of what we got, I think it looks about right, doesn't it? That doesn't look too far away from what we would have expected from the sketch. So we've done the other 2 points. Find the total of area shaded. So the area then, total area is equal to, well, it will be the area underneath the curve between the first 2 roots. Here, I'll call this x1, x2 and x3, the 3 roots from the smallest through to the largest. So it's minus this integral here to give that area, and plus the other integral. So it'll be from x1 to x2 of fx dx. So it'll be minus that because it was underneath the curve, plus x2 to x3 of fx dx. Okay, so let's do it then. Let's do that. These are awkward numbers, but we'll have a go. So it's equal to minus. Now this integral here, I've got to write down the cubic. There it is there, hiding in here. Minus 4x cubed plus 9x squared plus 10x minus 3. don't know if that's right. I'm just going to go back and check. Minus 4 plus 9. I've written plus 10 minus 3. Yeah, that's it. Okay. Dx between the x1 and x2. Plus the integral between the x2 and the x3 of the same thing again. So what do we get then? Let's work that out. It's equal to, okay, minus. The diagram shows the curve y equals f of x, where f of x is minus 4x cubed plus 9x squared plus 10x minus 3. Verify that the curve crosses the x-axis at 3 naught, and hence state a factor of f of x. Express f of x as the product of a linear factor and a quadratic factor. Hence find the other 2 points of intersection of the curve with the x-axis. And 4. The region enclosed by the curve and the x-axis is shaded in the diagram. Use integration to find the total area of this region. So I've summarized the question here. So let's have a look at this then. Here's our cubic equation. Crosses the x-axis at 3 naught. Verify it crosses the x-axis at 3 naught. So part 1 then. Let's have a look at that. Here, f of 3 we want, don't we? Is equal to. Now let's try and glance at our cubic at the same time. It's minus 4x cubed plus 9x squared plus 10x and then minus 3. The x value that I've put a bracket around instead of x is the value input 3. So let's input 3 in there, see what we get. Hopefully we get 0, and then we'll see that we have a factor. 27 times 4, so it's minus 4 times 27. This is 9 times 3, which is 3 lots of 27. And this is 30 minus 3 is plus another 27, isn't it? So in a sense you've got 4 27s here. Take away 4 27s, it's going to be 0. Tap it in the calculator if you need to. So by the factor theorem then, x minus this value is a factor of f of x. Okay, so we've done that then, and hence state a factor of f of x. Express f of x as a product of a linear and quadratic factor. So let's divide this in then, because this is the way the question is leading us to. It's leading us to do the division, long division of this into the cubic, which we can read off here. It's minus 4x cubed plus 9x squared plus 10x minus 3. And then we're going to find out how many times the x minus 3 goes into it then. So let's work that out here. So first of all, the dominant term x and 4x cubed. X goes into it 4x squared minus 4x squared, doesn't it? Times through minus 4x cubed, and then minus times minus is a plus. 4 3s are 12 x squareds. Take them away. See what we get. This take that cancels. So there's nothing there. That's why we're doing it. 9 take away 12 is minus 3x squared. 10x take nothing is 10x. And then minus 3 take away nothing is minus 3. Now turn our attention to this and adopt the same approach. How many x's go into this? Minus 3x lots of. Multiply through then. Minus 3x times x is minus 3x squared. Minus 3x times minus 3 is plus 9 x's. Take away the difference. This take that is nothing again. 10x take away 9x is x. Minus 3 take away nothing is minus 3. How many of these x's go into x's? It goes in plus 1. 1 lot of x is x. 1 lot of minus 3 is minus 3. Take them away, and we do get the 0, which is what we wanted. So x minus 3 goes into this cubic this many times. So here f of x then is equal to x minus 3. Now this has got a negative here, so I'm going to put a minus here and write this with a negative run all the way through it. So it's 4x squared plus 3x minus 1. Now, okay, so we've done that part then. Okay, part 3. Hence find the other 2 points of intersection of the curve with the x-axis. So the other 2 points here, well, we need to factorize it, x minus 3. So this will be part 3 now, we're going into here. So we need to factorize. I'm going to try 4x and x, naturally, to start with. It has to be 1 and minus 1. That's a plus, so I presume that would be a plus there and a minus. So here let's just check that. 4x squared plus 4x minus x is plus 3x. And then 1 times minus 1 is minus 1, so that's fine. So this tells us then x is equal to, when we solve this quadratic, minus 1. And x is equal to a quarter, isn't it? 1/4. And the other value is x equals 3 as well. So these are the roots for part 3. The other 2 points of intersection of the curve with the x-axis. Find the total area shaded. So it was the shaded region between the 3 roots, wasn't it, here? This is a negative. This value here was the minus 1, I think it was, wasn't it? This is a quarter. And this is the value 3. So we can see it's the negative part first, then the positive part to add together. So area, part 4. So the area, shaded area, is equal to, it would be minus the integral of f of x between minus 1 and the other root, quarter, as we said, plus the integral between the roots, quarter, the positive one here, and up to 3 of f of x dx. So that's equal to then, if we integrate this, we'll write it in capital F notation, so it will be f of 1/4, top value, take away the f of minus 1 here, plus, but it was a minus around all that, wasn't it? So minus this lot, plus f of 3 minus the bottom value f of 1/4. So that equals then, what have we got? We've got f of 1/4 with a minus, another minus here. We've got f of minus 1 and f of 3. So I'm going to write the f of 3 first. Plus, because we run the minus through here, f of minus 1. Then minus that and minus another one is minus 2 lots of f of 1/4, which is equal to, now we need to do the integration, capital F, don't we, and then input the values. So let's just do that somewhere. I've got a bit of room up here, so I'm going to write what f of x is here. It's equal to, integrate this, minus 4x to the 4 over 4, so it's minus x to the 4, because the 4's would cancel, plus 9x cubed over 3, so that would be 3x cubed. Plus 10x squared over 2 is 5x squared. And then minus 3x. So that's what we've got then. So let's take that with us. And then we'll move it down the bottom now, because we can write it in. Let's paste it here. Paste it in. Well, I've got to drag it, haven't I? Let me just get it and drag it then, in that case. Okay, so I've just put that down here for now. Okay. Right. Okay, let's have a look then at this problem. Now, so this thing here, we need to work out these values. So I'm going to use the calculator for that. So the first one would be 3. So it's minus. So I'm going to put answer. Right. Answer is 3. No, I'm not. I'm going to just write the polynomial. So it's minus bracket 3 to the power 4, then plus 3x cubed. Oh, it's minus 3 to the 4 plus 3 times bracket 3 bracket cubed plus 5x squared squared, that should be, shouldn't it? And then what have we got? Minus 3x bracket. So that's the polynomial, and we get 36. So I'll put that in now. That's f of 3. Now I want f of minus 1, so just toggle back and change all the 3's to minus 1's in where the x's values are. So let's do that then. This value is minus 1. Got to change it 4 times, haven't we? Here, minus 1. Here, minus 1. And one more place, I think, if I remember rightly, is here. Put a minus 1. 4. So that'd be plus 4 minus 2 lots of f of a quarter. So let's put that in. Now we need to put in 0.25, don't we? Plus 0.25. So it's 0.25 here. And then there. And here. And then move along. One more place, I think, I believe. And put it in here. 0.25 equals 101 over 256 with a minus. Minus 101 over 256. So we've got 40 minus 202 over 256 is equal to, so let's tap that in then. So 40 minus, plus rather, because it's a double minus, 202, oh that's fine, I'm happy with that, because it's 40 and 202, well that goes in, the 2 divides into 256, so I can simplify the fraction here. So it's going to be plus, and it will be 101 over 128, isn't it? There's the answer, units squared. Long question.